This is Michelle Solicito, and this course is designed to help you pass your AWS Solution Architect Professional certification. So this diagram shows you the different paths you can take towards AWS certification. So the basic, easiest one is the cloud practitioner, which is kind of foundational. You don't really need to know a lot in practice of actually using it hands-on, using AWS hands-on for this one. A lot of this can just be theory, and you can pick it up in books about AWS and so on. It's pretty easy. Most people here would be able to pass it no problem, and so on. The second level is associate. Associate level gets quite difficult, I think. Solutions architect certification is quite tricky. They have a lot of things you need to know. It's the breadth of knowledge rather than the depth of knowledge, but you have to know a lot of things to pass. And then there's developer and SysOps admin. So I've got Solutions Architect Associate and I've got SysOps Admin Associate. I can't really talk about developer because I haven't done it, but I think it's pretty similar. There's a lot of information you need to know, but not at a lot of depth in SysOps Administrator and Solutions Architect Associate at least. But for both of those, I think some hands-on knowledge is really important too. So just so you know that. Now, the professional level is a whole different animal. I've just passed my Solutions Architect Pro, and it took me, like, I've been working in AWS for 5 years, and I had to study really hard for weeks and do a couple of really good training courses. So that's kind of a really high level. Professional is, a really high standard. And I believe the DevOps engineer is just the same in the sense of you have to know a great deal to pass it, both in depth and breadth. For DevOps engineer, it's like SysOps administrator, but combined with developer at associate level, but you have to know it at that nth level, that you need to know a high degree of that information. So unless you've actually been doing DevOps in practice for years on AWS, you might not pass that. It's quite hard. And, you have to still study really hard and do training courses and so on. So just so you know, professional is that kind of level. Now, the specialty exams are a bit different. I think they are, you have to know a lot of stuff about that particular area, but it's just that area kind of thing. So I've just passed the security one and I'm taking the big data one soon. I'm studying for the big data one now. So for both of those, there's the depth in that particular area, but you don't have to know very much else about other areas of AWS. So just so that you know that that's kind of what's at the specialty level. So if you want to start learning to pass one of these certifications, whether it's the foundation one or whether it's right up to the specialties or the pro exams, the best place to start is here, www.aws.training, and go to the certification link. And the certification link has a lot of information about how to get to the level where you'd be certified. So which courses to do, which which things to learn. There are some free training courses up there. There are a lot of guides to how to get certified. There's also, that is the way that you would actually take the certification exams. So they have a page where you can actually sign up for an exam or sign up for a practice exam if you want to practice before you take the real exam. And by the way, I do recommend, especially at the associate level and the pro level, take a couple of practice exams before you actually take the real exam. It makes a big difference knowing what to expect in the exam. So this is the website, www.aws.training, and there's a lot of stuff up there. to help you get certified, and then once you're certified, to help other people to find out that you're certified. For example, there's a website that you can send people to where it'll list all of your certifications, and it's kind of rubber stamped by AWS, so that they've certified it and said you really are a certified person. As I say, there's the learning library there, the training, and so on. So it's a really good website. So this is the page where you would go to sign up for your actual exams, for your practice exams. On the right, you can see it says schedule new exam, and manage the exams and so on. So this is all within that training website that we just pointed to before. Once you click on certifications, you get to this basic website. So this website, if you look at the top, on the top left-ish, you can see your upcoming exams, so any ones that you've already signed up for, any previous exams, any certifications you've achieved, any badges you've achieved, and you can share your transcript. So that's how you can let people know that you've really got these certifications. And again, I do recommend you take a practice exam before you take the real exam, and this is a list of the kind of options you're going to get when you get into that website. And as you can see, there's a practice exam at the bottom there for the associate, and there's also the main exam for the associate. Make sure you pick the right one when you're signing up. The practice exams are about $40, and the actual exams are between $150 and $300 depending on the level of certification. So if you're going to go for like Solutions Architect Pro, that's going to be like $300. But if you're just doing the associate level, that's going to be about $150, something like that. They vary the cost of these courses, but that's roughly what it is. And again, this is on the same website. This is the learning materials, the learning library. And there's some stuff there that costs money, but there's a lot of stuff there that's free. Some of them are on-demand videos, some of them are actual lessons and training courses, and so on. But it's a lot of it's free, and if you search by the thing that you're particularly interested in, there's some really in-depth stuff in there too, and there's also lots of introductory stuff. So just look around and see what you can find in there. The first thing I want to say is that no one source is going to get you through the Solution Architect Professional certification. You might manage that with one of the other certifications, the less professional ones, but the Solution Architect Pro is a really tough certification. So you're going to need lots of resources. So I start off here with some of the resources I suggest that you can use. There are many more, but these are kind of the best ones, I think. AWS has a certification website that contains a lot of training, a lot of introductions to different technologies. Some labs are available in there, some practice exams, and so on. So there's a lot of stuff in there. There's a link there to explain everything you need to know about how to take a certification, how to prepare, and that kind of thing. You'll find those all over the web. There's lots of guidance on how to prepare to actually take the exam and so on. The next link is for documentation of all the AWS products. I suggest you look at all of the products. Each of them has its own page. Definitely look at all of those and look at some of them in depth as well, and also the white papers that are published around those. And in the AWS training area, there's a lot of training to help you pass the Solution Architect Professional. So that link is there too. There are lots of other resources. There are lots of courses. There on Udemy, there are a number of courses. On Pluralsight, there are a number of courses. I suggest you take at least 2 or 3 courses so that you get a good rounding of the whole thing. And of course, do a lot of actual practical work in your job. So that really makes what you've learned sink in. The more practical experience you can get, the better. So this course is just to help you. Don't see it as the be-all and end-all of certification. And this is just a couple of suggested resources if you're going to take the higher level exams. So the associate exam, the Solutions Architect Associate exam, there's a number of websites you can go to learn for that exam. The iCollege exam is fairly cheap. I think most of their courses are about $19, and you can get the bundle for about $60. So that includes a lot of different exams covered in one set of courses for $69 or something. So that's a really good option. A Cloud Guru is a lot more expensive, but it's very, very good. So if you're really serious about this and you want to go all the way to Solutions Architect Pro, I highly recommend that. And this course too will help you get to the associate level. And there's part of this course eventually, remember there's going to be lots of sections to this course, eventually will get you to the pro level too. But we'll talk about pro level on the next slide. So if you're thinking of going all the way up to the pro level, I highly recommend you get both of these courses, the Udemy course and the Cantril course. Obviously, you should get the AWS Associate Cert first before you even try the professional exam. But then I also recommend you getting these two courses, the Udemy one and the Cantril one. They both cover a lot of depth on the pro exam, but in different ways. So I think both of them together will get you to pro level. And recognize that there's a lot of content in the Cantril one. So it's going to take you, a few weeks to do it. And that's even if you're doing it full time. Also, this training course eventually, hopefully, will get you to the pro level. But right now, I'm only at the intro level. I will be doing a series of these courses. So once you get to the end of the series, you should be able to pass pro. I've included this slide so that after you've watched this whole thing, you can go back and actually look at it in detail. It's an AWS mind map we developed for a company I worked for called Micro Focus. And the mind map includes just about everything I think you need to know about AWS, so all the different areas. And if you have to scroll right into it and zoom right into it, but once you get in there, you'll see the detail of each of the sections and what you need to know, kind of thing. So I think it's a really good way of planning for your certification exam to make sure you know everything you need to know. So let's go straight on into the AWS Solutions Architect Associate information. So in the old days of websites, you would have to, in your company, for example, you would have to order in a web server, and the web server would take days to come. You would have to plan for that. You'd have to make sure it had the right CPU size, the right RAM, the right hard disk space on it. And then once you actually got it into your business, you'd have to first of all check all the parts and make sure they'd got it right. And assuming they had, then you would have to configure it. You'd have to install the operating system. You'd have to do all kinds of configuration before you even started to put your website onto that web server. And then you might decide that you actually needed 2 web servers, or you needed an application server as well, especially if you needed to grow. For example, if a marketing campaign came up and suddenly you were going to get hit by thousands or even millions of hits, you might need, a number of web servers just to cope with that marketing campaign. And once you've paid for all those web servers and got them all configured, you're not going to just sort of turn them off or what have you. So then you've made all this huge investment just to cope with maybe a couple of days of a marketing campaign just because they did something on the TV about your product or something. So this is how the old days used to work. And this is why we needed cloud really to help us with this. So now we have AWS or other versions of cloud, which basically make it really easy to create a server in the cloud. You literally, you click on a button to say you want a server in the cloud. You might choose exactly which kind of server you want. Like you might say, I want a Windows server rather than a Linux server. You might say, I want this amount of CPU or this amount of RAM. But pretty much you're just pointing and clicking in the cloud console, in this case in the AWS management console. And within a few minutes, you have a web server just up there running. And you can scale up quickly, so you can add more web servers quickly. You can scale down quickly, which is really important, so you can save money when you don't need to have lots of web servers running. For example, in the previous analogy where the marketing campaign meant that over the weekend perhaps there was something on the TV about your product, so you had to have lots of web servers to cope with demand, but then the next week it all goes back down to normal, so you can just turn off all of those extra web servers, and you can do that really easily in the cloud. The other benefit is that you don't need as many techies supporting your infrastructure, because it's so easy to do everything in the cloud that you really just don't need those people. Plus, there's a lot of the stuff that would normally be done to maintain these servers that that AWS does for you. So we'll go along with that as we go along. You'll see the sort of things that AWS does for you. But basically, that is the big benefit of using cloud to install web servers, or to create web servers and to create machines in the cloud. And also there's a lot of basic stuff that you don't have to worry about, things like certain types of security, certain types of compliance, the kind of things that sometimes in a company take a lot of time to work out. In the cloud, a lot of that is done for you by AWS or Azure, depending on who you use. So I'm going to start off with some of the basic, foundational concepts that you're going to talk about in cloud quite a lot. And for the cloud, the foundations certifications, you're going to need this kind of information especially. So one of the things you probably hear talked about a lot that you may not understand what it means is IaaS, which is IaaS, or PaaS, which is PS, or SaaS, which is SaaS. So depending on whether you're English or you're American, you might pronounce these differently, but that's how I pronounce them. So infrastructure as a service is all about what we just talked about, basically being able to set up web servers and computers and app servers and so on very, very quickly, very, very easily in the cloud. You don't have to plan ahead. You can literally just decide today that you want a server, and you can have it up within a few minutes, maybe 10-15 minutes. AWS handles the basic hardware issues and the basic setup. You have full control over the actual operating system. So if you want to upgrade the operating system, if you want to configure the operating system in a particular way, you can do that. And you can test easily and flexibly using that infrastructure. So it's easy to add another web server, and it's easy to bring those web servers down if you need to, that kind of thing. And we use IaaS in the lift and shift paradigm. So what's the lift and shift paradigm? So the lift and shift paradigm is the idea of taking a server that you have on-premise in your own company and basically just copying it up to the cloud. That's really what lift and shift means. You're basically taking exactly what you have on-premise and just copying it into the cloud with hardly any changes, if any. So this is the best way of doing that, infrastructure as a service. So you're literally just creating a new web server in the cloud with the same code on it, maybe the same web service on it, as you had on your on-premise site. So this is called lift and shift. So that's one set of terminology you need to know: lift and shift and infrastructure as a service. They kind of go together. Now, the second option is platform as a service. Now, this is where you don't even have to worry about web servers or application servers or computers in the cloud or anything like that. All you have to worry about is your code and writing your code. Now, this is where you don't manage any infrastructure, you don't manage the operating system, you don't manage the environment at all. All you do is write some software and it runs in the cloud, and you don't even need to know how it runs. You don't need to know about scalability. If your marketing department has something on the TV over the weekend, it will automatically scale up to meet any demand and also scale back down again afterwards. So you don't have to worry about scalability either. Of course, that comes at a cost, but it also saves money because the piece of code that you're running is only charged when it's running. So unless you're actually using it, you're not charged for it. So it ends up actually costing less money in most cases if you plan it right and if you write it right. And we'll talk in more depth about what that's all about. But that's platform as a service, and we use that for the optimize for cloud paradigm. Now, what does optimize for cloud mean? So what that basically means is, on premise, you might have had just a web server with a website on it, and when you lift and shift that to the cloud, it would literally be on another web server, or you might call it a virtual machine in the cloud. Okay, so that virtual machine would sit there running like a web server and just accepting traffic from the internet. But that could be a whole web server used just for a very small web service or website. So with platform as a service, you're basically optimizing what you had on premise or what you had in your infrastructure as a service. You're taking that and saying, how can I best use the cloud for what I want to do? And quite often that does not entail using a whole web server. Quite often that means you can change your code slightly and it will run just on demand and running platform as a service. So this is kind of like the second step in the cloud for most people. So they start off with the lift and shift paradigm, and then they start optimizing parts of the system to run as functions in the cloud or as containers in the cloud. You might have heard of those. And that's when you're really using a platform as a service rather than an infrastructure as a service. And we'll go into more depth of that later. So if that doesn't quite make sense yet, it will later on, I promise. So you simply write the software and it runs in an AWS environment where AWS are basically managing everything. Now, software as a service is a bit different. Software as a service is when you're using a tool in the cloud, really, to run as software that someone else has written for you. You don't even write any software. You use that software, you use that tool in the cloud, and they handle not just handle all the infrastructure and the setup and the system environment and all that kind of stuff. They also handle configuring of users, configuring of the software. They handle any bugs in the software. They do all of that. So an example of that, I'm sure you've all used at least one of these examples. Office 365, which is now called Microsoft 365, offers this as software as a service. So basically, if you use the cloud version of Office 365 or Microsoft 365, Microsoft has written all the software for you. They run the software in the cloud for you. They provision new users for you. They provision licenses for you. You don't have to worry about anything except using that software. And the same thing is true of Salesforce Cloud, the Atlassian tools. So the Atlassian tools are things like Bitbucket, Jira, Confluence, and there's a whole load of other software that's run in this model, software as a service. And it basically means you don't have to have any infrastructure. You don't have to have any software. You don't have to maintain any software. You don't even need any programmers and so on for this particular use of the cloud. And of course, a lot of these software as a service companies, their code is running in a cloud environment, either on AWS or on Azure or on Google Cloud or so on. So then on the right, you have some slightly different stuff. So here you have database as a service, table as a service, and function as a service. Now, strictly speaking, function as a service is kind of like platform as a service, but it's where you just run one function at a time. So rather than having a whole platform where you run lots of software in different ways, function as a service is just where you just run one function at a time. So you don't have to worry about, not only do you not have to worry about the web servers and the control and the security and that kind of thing, you don't even have to worry about setting up the environment in which your platform runs, your software runs. All you have to worry about is writing the code and loading it up to AWS, and they take care of everything else. Table as a service is really like having a database as a service where AWS manages the database, but the table as a service is where it actually manages everything. All you have to worry about is the table itself. So you don't even have to write backup software, restore software. You don't have to worry about failover and security issues and so on. You don't even have to, for table as a service, you don't even have to worry about writing the schema, um, any of the replication details, that kind of thing. AWS does it all for you. So they're all different ways of using a service within AWS, basically. So we've got some of the general language and terms that we've talked about, IaaS and PaaS and SaaS. Now we're going to talk about some AWS specific terminology. So in AWS, each section of tools has a name. And in this case, it's compute. We're going to deal with compute first. That's kind of the biggest section. So compute is really anything that computes, anything that does computation, really. So we have some really weird names for some of these services, and I'm sorry, I apologize in advance. I can't help it. This is what AWS decided to call them. So EC2, Amazon EC2 is Elastic Compute Squared. Okay, so EC2. So elastic means it changes and varies according to demand. Compute means it does computation, and squared is meant to mean, it does it to the power of 2. It does it really, really well. So really, when they're talking about EC2 instances, they're talking about virtual machines. Just think of EC2 as virtual machines and you'll be fine. They call them virtual server instances in the cloud, but it's basically a virtual machine in the cloud. So that's all you really need to know. So this is where, you have a server on premise and you want to move it up to the cloud, and you'd use an EC2 instance for that. And there are lots of types of EC2 instances, and there are lots of sizes, and you can have more RAM or more CPU and so on. So we'll go into all of that later on. So then the second thing is Amazon ECS, EKS, and Fargate. I hate these names because they are not intuitive. ECS is Elastic Container Service. So again, it's elastic because it moves up and down according to need and demand. Container. So a container is basically any small piece of code wrapped up in itself in a little tiny object called a container. And there are lots of ways of doing that, but the most famous way is Docker. I don't know if you've heard of Docker. Docker is kind of a coding environment for containers that runs on just about all the operating systems available today. So that's what ECS is. ECS is for containers in the cloud to be run kind of in a managed fashion, ECS. So it's Elastic Container Services. So it just allows those containers to be managed and run in a nice way, really. Now, EKS, just to confuse you, EKS means Elastic Kubernetes Services. So Kubernetes is a way of managing containers that already existed kind of outside of AWS. It's kind of a bit like ECS, but it has a few extras like really good load balancing features and really good security features and ports and so on. So EKS is kind of a management service that's a little bit better than ECS, I guess. And also Kubernetes is a fairly common way of managing containers in the industry generally. So for example, this is Amazon EKS, but in Azure, they have an AKS, which is Azure Kubernetes Service, and Google has their own Kubernetes as well. So just so you know, Kubernetes is quite common, and you're probably going to see more and more of Kubernetes and less of Docker and the container management service. So then Fargate is a bit like running containers in the cloud, but Fargate is for longer running containers. So most containers are short running, they just run for a quick amount of time, and they're pretty easy to start up and shut down. Fargate is for stuff that would take a couple of hours or half an hour, anything that's longer running, basically, and we'll talk about Fargate later. AWS Lambda is put on the right here. I think it's actually part of the middle section to some extent, but it depends how you look at it. So AWS Lambda is AWS's name for functions in the cloud, really. And it's serverless, which means it's PaaS, P-A-A-S, platform as a service. So serverless and PaaS are really the same thing. Basically, you don't have to configure your server. You don't have to install your server. You just run the function in the cloud. So that's what Lambda is for. Lambda is for running functions in the cloud effectively. So just so you know, Azure has an equivalent called functions. So Azure functions and AWS Lambda are pretty much the same thing. You'll come across this later, this terminology, but functions are supposed to be stateless, and there's a reason for that, and we'll talk about that later. And functions also respond to triggers. Usually something starts them off, starts a function off. So starts a Lambda function or an Azure function off. So it might be a trigger based on time, or it may be a trigger based on something else that's happened to another service in AWS. All kinds of things can trigger a function. So just so you know, that's roughly what that is. We'll go in much more depth of these things later on. So just to get another little bit of terminology out of the way, EC2, as we talked about, was elastic compute squared. So it's basically the virtual servers or the virtual machines in the cloud. Here's some terminology around EC2s. So an EC2 server is created from an AMI. An AMI is the application machine image. So or AWS machine image. So the machine image is what's used to create an instance. So for example, when you create an instance, you select which machine image you want to use. And the machine image might be a Linux or a Windows image. It might have more CPU or less CPU. It might have more RAM or less RAM, and so on. So you use an AMI to create any instance. And then an instance is created inside what's called an availability zone, or an AZ, as you can see on the right-hand side here. An availability zone is really like a data center, but nowadays it's more than one data center, but you can think of it as like a data center within a region. So a region might be the Northeast United States, for example, and that would be US-East-1. US-East 1 is a region, and within that it has a number of availability zones. So you might have AZ, or you might have US East 1A and US East 1B, and they're two different availability zones within that region, that Northeast America region. And then there's also a region called US West 1 and US West 2, and those regions have their own availability zones, and so on. Normally there's 2 to 3 availability zones in a region in AWS. Azure is slightly different, but it still works on regions, and it also has availability zones, but some of their availability zones are a little bit different to others. So if you go into Azure, that's something to look out for. Within an availability zone within AWS, you have VPCs, which are virtual private clouds. Now, these are basically your own private network, your network where you can put your own web servers, your instances, your EC2 instances, or your VMs, your virtual machines, same thing. So your virtual VPC, virtual private cloud, is where you're going to put all of your basically web servers in the cloud, and it's a network, and it's called a VPC, virtual private network. Virtual private cloud, sorry, but you can also have a public one, so you can have a virtual public cloud as well. So just to confuse you, the public one will allow people outside of your network to get access to some of the stuff inside your network, for example. So that's just some terminology there. So a particular instance, an EC2 instance, remember that's a virtual machine, can be running or it can be stopped. And that just means it's either accepting requests from other places or it's not. And when it's stopped, you're not paying for it. That's the important thing. So one of the big things in AWS is how to save money in the cloud. And it allows you, if you're clever about it, AWS allows you to save a lot of money in the cloud. And one of the ways is if you've got virtual machines, you can stop them if you're not using them. So that's a great way to save money. So that's the terminology I wanted to go over related to EC2. We're going to go into a little bit more depth about some things in a minute. Just a quick little bit of in-depth on the AMI because it does come up in the exam a lot. So an Amazon machine image or AWS machine image, it provides all the information needed to launch an instance, to launch a virtual machine. You can launch many instances from a single AMI. So it's kind of like a template for launching a number of instances, a number of virtual machines. An AMI includes a template for the root volumes, so what operating system it has, which applications are on it, and so on. Also, the launch permissions that control the AMI, the AWS accounts on the AMI, and so on. And some block device mapping, which basically it's like the hard disk. It kind of specifies what the hard disk looks like, basically. So to choose an AMI, you can either go into the AWS console here and select which AMI you want. And as I say, there's Linux ones, there's Windows ones, there's Red Hat ones. And you can look at the RAM and the CPU and the volume type and so on and decide which one you want there. Or also, there are some on the marketplace. AWS Marketplace is like a shopping center where you can go and find the exact type of web server you really want. So it might be set up with a particular piece of software that you need. For example, there's one for some databases, like there's a Vertica marketplace install, which will basically set up your virtual machine to run a Vertica database. Vertica is a data warehouse, and so on. So there's the AWS marketplace gives you a lot of choice about what you want to configure your web server to do and to run, which software to run, and so on. So when you find the ID of the AMI that you want to launch, you can just select it using that blue button on the right hand side there, the select button. Or if you want to do it more in a way that you have more control as you get more confidence later on in AWS, you can use what's called the command line interface, CLI, or the API, which is the application programming interface, the API. And those two allow you to set up, to do just about anything actually in AWS. But in this case, it allows you to create an EC2 instance, a virtual machine, with a particular image, so either from the marketplace or from this the console within the AMI console. And you can say how large you want the instance to be. So you can say, for example, if you look at this down here, this actual command, you can see that the instance type is a large. It's 8 times large. It's a C4.8 times large. And you can say, I want 10 of those. So you can set up 10 just at the command line, just by writing that into the command line. You can set up 10 instances, all of the same type, all of the same image, just by running that command line. And it will take a couple of minutes to set it up, and that's it. So, you know, it can be really simple to do some really complex things. So here's some other EC2 terminology. So we've seen the AMI and the instance and the VPC. Just below the VPC here, you can see EBS. So EBS is Elastic Block Storage. Why they call it that, I have no idea. It's just to confuse you, I'm sure. EBS basically means a hard disk. Now, in most cases, these hard disks work just like, have you ever used those passport hard disks? You can get them in Micro Center and so on, where it's basically an external hard disk, and you can take that hard disk from one computer to another and copy files to and from different computers, or you can just use it as extra storage on your computer and so on. And that's called a passport hard disk usually in the real world. Well, in AWS, they call it an EBS. So an EBS is elastic block storage, and the reason it's called that is elastic because it can go up and down. You can increase the size of it, and you can move it from one computer to another. Block because block storage is slightly different to file storage, but basically when you're using it, you don't know any different. The block storage just is a little bit more efficient as far as the cloud is concerned. So that's why it's called EBS, elastic block storage, elastic block storage. And then you can see under here it says EBS snapshots. So basically, so long as you configure them correctly, AWS will take a snapshot of your EBS at intervals so that you can always restore back if you lose any data on your EBS. So if you accidentally delete some data on your hard disk, or if you lose it some other way, something happens, you can always restore it from a snapshot. So AWS will automatically take snapshots for you so long as you configure it correctly. Those snapshots live in something called S3. S3 is another really badly named service. So S3 means storage, and instead of squared, it's to the power of 3 because it's so amazing. So it's amazing. It's Amazon storage, basically. So if you think of S3 as storage, data is stored in S3 in something called buckets, and again, very badly named. To think of a bucket as a folder. It's just like on your hard disk, having a folder in your hard disk, and the data can get stored in those folders or those buckets. So each bucket in S3 is treated differently according to, for example, security purposes, access purposes, and so on. So that's why it's called a bucket rather than a folder, because it's kind of an individual section of the storage. But to me, it's just like a folder. So that's just some terminology to get used to. So hopefully I've not completely confused you all with all those terminologies. I hate the fact that they use all these terminologies that don't really make any sense to anybody. Just to go over this quickly, in Azure, VPC is called a VNet, a virtual network. I think VNet is much more understandable because VPC, virtual private cloud, and that doesn't really mean to me, VPC is not intuitive, whereas VNet, virtual network, makes much more sense to me, you know. And in Azure, you have something called file storage, which is basically what EBS is here. File storage makes much more sense because that's what it is. It's file storage. So just don't worry too much about AWS terminology. Try to just remember what it really means. So here I'm going to show you, once you get into AWS, how you can use AWS for EC2s, for virtual machines, and so on. So first of all, I've recently used EC2, so it's already in my recently visited services. But if you came to this when you first signed up to AWS, you might want to choose from this services menu here and go to EC2 here. Or you might want to go up here and select EC2 in here and go to here, EC2. Either way, you would come to this dashboard, and it tells you how many instances you currently have running, how many virtual machines you currently have running, and all the other information here is all related to EC2s. We'll go into some of this later in the course. So let me go and see which instances I've got running. I've got a server that I set up earlier today, and it's an instance type T2 micro. We'll talk about that later, what that means. This is the ID of the instance. It's currently in a running status, and its status is good. It's checked the two statuses that kind of run at the beginning. It's in this availability zone. Do you remember we talked about there being a US East 1 and a US East 2 region, and each one of those has availability zones. So US East 2A is one of the availability zones within the region US East 2. Okay. This has a public IP DNS for this instance, for this virtual machine. That's the DNS. So basically, if I typed in this DNS here, I would actually go to that website that's on that machine. And this is the IP address of that machine. So this is, I can access this IP address by doing a ping and that kind of thing to that IP address. There's no monitoring enabled right now. We've got no IPv6. So IPv6 and IPv4 are different ways of addressing your computers, your instances, your virtual machines. So IPv4 is the most common way right now, but IPv6 is a new way of addressing that will cater for the future. So we're gonna move more towards that in the future. An elastic IP address is really an address that kind of sticks to particular computers at a particular time and can move around, and we'll talk about those later on. What else? There's not really much else we need to know about that. Okay, so let's look at the instance. You click on the instance here and you can see all about that instance. Again, you can see the private IP address here, the public IP address. We could open this IP address. This is like going to that IP address in the URL, but it's probably not going to do very much right now. Probably nothing. Okay, we'll just quit that for now because there's no actual web server running on that machine right now. It's got its own address within Amazon. So the address is an EC2 address. It's kind of got its IP address in here. So if you look at 13.58.187.18, you can see it's the same IP address. The US East 2 is the region. And then it's .compute.amazonaws.com because it's one of the compute areas of tools in AWS, basically. So that's the DNS, that's the long address, if you like, of my computer. The instance type, as I said, was T2 micro. We'll talk about instance types, and it's inside a VPC. Remember the virtual private cloud, which is like a virtual network, like an area of network where I can store my my web servers, my virtual machines. And this VPC has subnets in it, one of which is this subnet, and this is the subnet where my instance actually lives. So a subnet is part of a VPC. It's a smaller part. Okay, so that tells us some things. If we go down here, a lot of those details are kind of repeated here. If we go into security, you can see who the owner is. That's me. That's my ID. The security group that's attached to this virtual machine. So a security group is a way of saying this virtual machine belongs to a group of virtual machines, and they're all going to have similar security attached to them. For now, just think of it as that. If anyone knows what a firewall is, this is kind of like a firewall that's attached to a group of virtual machines. So port ranges in the security group, at the moment, my security group allows all port ranges into my computer, my virtual machine. So if I wanted to limit the number of ports that are open on my virtual machine, I would do it here in my security group. I would say which outbound rules are allowed and which inbound rules are allowed. So you can see inbound rules here, outbound rules here. So I would stop certain protocols being able to get in, certain ports being able to get into my virtual machine. So let me show you how you create a new instance. So let's go back to instances here. And if I want to launch a new instance, I can say launch instances. And what it's going to do is it's going to let me choose an AMI. We talked about that earlier, an Amazon Machine Image. So in this case, I've got all of these choices. So for example, I can choose a Linux, which is free tier eligible. So whenever you start up a new account in AWS, if you want to, you can use the free tier, which basically means you can do a lot of playing around for completely free. So this is free tier eligible, which means Amazon will let you use this machine for free. I can choose a 64-bit x86 or an ARM. Those are just different types of CPUs that can be run, that this virtual machine can be run using. So I can choose here which CPU I want. There's Mac OS with different operating systems. There's Red Hat with different operating systems. If I want an RDS database instance, which basically means a virtual machine that's running a SQL Server database or something like that. You've got these choices here. You've got Aurora, MariaDB, MySQL, Oracle, PostgreSQL, or SQL Server. If I want that, I can just launch an instance that has the database already installed and everything, so I don't have to worry about how to set that up. I can run Ubuntu. I can run all kinds of Microsoft Windows. There's all kinds of servers here for Microsoft Windows and so on. So these are all the choices. So because I am free tier eligible, I'm definitely going to pick a free tier eligible option. So I might say, let's say this one, because it's a 64-bit Windows Server 2016. So this is like the data center version. So actually, let me choose the is there a lower version? Yes, there's a lower version here. Let's use this one. So Microsoft Windows Server 2019 base, free tier eligible. Should I use that one? I think that's the right one to use. Yeah, that's the right one. So it's a data center version and it's a 64-bit. So I'm going to select that one. In here, it's going to show the types of virtual machine I can choose. Again, there's a free tier eligible, so that's looking promising here. But I'll go down and show you the different options. So T2, just remember that's kind of general purpose T2. And you can have different sizes, so you can go large, extra large, 2 times large. There's also a T3 that is also general purpose. But the difference between a T2 and a T3, as you can see, is there's more CPUs and memory on the T3 than there are on the T2. So you can see that goes up. EBS only, which means, those passport hard disks that I was talking about. That's the instance storage that you're allowed to use here. EBS optimized is available only on the T3s, not on the T2s. So, you've just got to look down here and see what's important to you. Different network solutions. So T3 is better for high network throughput and so on. And there's all these different types available. There's T4s, which are another kind of general purpose. C4 is anything starting with C is normally optimized for compute, C for compute. You've got lots of different types there. What else have we got? D types. So D is usually for database, usually. G is usually for graphics. I is IOPS optimized. So you'll see the SSD options starting to appear here. SSD is like a really fast hard disk drive. So that's why it's IOPS optimized. IOPS means input output optimized. So SSD is faster and in input output to a device to write to disk. So that's why that comes up. So that's why M is sort of more, M for more. It's like a general purpose, but more. It's kind of better. You can see things like 256 appearing here, faster network speeds, and so on. So I call it more. Then you go for R, which is RAM. So it's RAM optimized. So you'll see a lot of RAM on these ones. You can see the RAM goes up very high very quickly on these ones, and so on. What else have we got here? X is extreme, so that's a supercomputer really, not quite a supercomputer, but very high RAM, very high speeds of IOPS, good network, and so on. So depending on what you need and what you want, you will launch a different type of EC2 instance. So in this case, I'm just going to pick the general purpose, low level free tier eligible with a hard disk like a normal passport hard disk, and low to moderate network, because I'm just doing stuff as cheaply as I can right now. If you're looking for speed or RAM or that kind of thing, you'd pick another one, but I'm just picking something easy. Now at this point I could just review and launch and it would just literally start up my instance right there and then. But if I want to add more configuration, I'm going to go to the next, and the reason I'm doing that is so that you can see what all the options are. So let's go to next. So I could select here to start up 10 instances if I wanted to. And I could also say I want some of them to be spot instances if I clicked here. So then I'd be able to say, this is the current price. Am I prepared to pay that? Or do I want to make a bid for, like, if I'm only prepared to pay 0.0080, then I might put that in here and say, I'm not prepared to pay 81. I only want to pay 80 or something like that. So that's how you would do that. So I'm not going to go for spot right now. I'm just going to create a normal instance. I want it to happen in my virtual PC, my virtual private cloud. If I wanted to create a new VPC for it to go in, I could here, but I've already got one, so I don't need to do that. The default subnet for my VPC would be the 2A probably, and I can choose to go into a different availability zone within my VPC if I wanted. As you can see, US East 2 here has 3 availability zones, A, B, and C, but I can choose to put it in any one of those. But I'm just going to go for the default right now and let it create it in that one. If I want it to auto assign a public IP, I can enable that here. If I want to put it into a placement group, I can here, which basically means it's like a resource group in Azure. This is like a group of instances that I want to manage as a group together. Usually I would manage them so that they're all in the same availability zone or they're all in different availability zones. So if I click on here, I can say add to an existing placement group or create a new one. Add to a new placement group. I could create a new placement group, let's say placement group 1, and I could say cluster in the same as availability zone or spread them between availability zones. And there's also partition, which basically means some of my virtual machine should go in the same as availability zone and some shouldn't. So I'm not going to add to a placement group in this particular case. Capacity reservation, this is where I'm going to reserve capacity, but I'm not going to do that right now. And I'm not going to join a directory. My IAM role, I'm not going to assign a role to this instance right now, but if I wanted my instance to always access a particular database, I might give it a database role, for example, so that it can get to that database and that kind of thing. So shutdown behavior, when I stop this instance, do I want it to terminate or do I want it to actually stop? Now that might sound like the same thing. If I just terminate, it doesn't actually die. It stays there with the same data on it and comes back later on when I start it up again in the same condition as when I left it. It's kind of like your laptop when you go into sleep mode rather than when you actually restart your computer completely. So in this case, I'm actually going to just say stop. But if I say terminate, it will actually keep the current state when it restarts, that kind of thing. And then these are all the different options for stop behavior that you might want to hibernate and so on. Do I want to protect against accidental termination? Because I might lose some of the data on my machine if I accidentally terminate, I could protect against accidental termination here. I'm not going to do that right now. Monitoring, if I want to monitor this virtual machine and find out what's going on the virtual machine, I can do that normally. Oh my God. Okay. So virtual machine, I'm sorry, I thought I'd done the wrong thing here, but I haven't. It's okay. Okay, so if I want to monitor my virtual machine, I can monitor it using CloudWatch normally, and I don't have to click this at all. If I want detailed monitoring, which is over and above the normal monitoring, then I would have to check here, but notice that additional charges apply. Sorry, I thought I'd incurred more charges by selecting that, but I haven't, so ignore that. I thought it says additional charges have applied, but it says apply. So only if I click on here will the charges apply. Okay. So tenancy is the thing where I said about dedicated, where I can say I want my virtual machine to be on a dedicated hardware instance or host, or I can make sure that nobody else shares the hardware with me. I'm not going to do that. I'm just going to run on a shared, because for most cases that doesn't matter, because Amazon isolates accounts so that no one else can access my virtual machine that I don't want them to access. So that's okay. And I don't want any special stuff like elastic graphics or anything like that. So I'm just going to ignore those things. Is there anything else? Okay, so this is all the selection, all the options in here. Next, I'll add storage. So this is what I was talking about, those snapshots and sorry, not snapshots. This is what I was talking about, those hard disks that are like uh, passport hard disks. So in this case, it's going to give me a default one, which is my root device. It's got a snapshot attached to it, which is the backup. It's 30 gig by default. I can make that a terabyte. I can make it much bigger. And it's by default is general purpose. Okay, I can get a much faster hard disk by going for an SSD if I want to, but by default I get this one. That's fine. So I don't want it encrypted. If I wanted it encrypted, I could choose that here, but I don't. So I'm going to just review and, oh no, I'm not going to review and launch. I'm going to add tags. Let's look up the tags. So here you can use tags to identify a particular group of virtual machines or something about that virtual machine that you want to record. So in this case, I'm going to just give it a name and I'm going to call it which server 2 because I've already got a which server 1. So I'm going to call it which server 2. And I'm going to configure the security group now. So the security group is the firewall or the group of rules that I want to attach to a particular group of virtual machines. So I can either select an existing security group that I already have, which is this one here, the default one, or I can create a new one. In this case, I'm just going to select an existing one, which is this one. And then I'm going to review and launch. So just so you know, the inbound rules and so on here allow all protocols and ports. I think I showed you that earlier. So that's by default what I'm going to choose. If I wanted to change that, I can change that in the security group. So I'm going to review and launch. So it's just confirming here that I want a Windows Server AMI. So this is basically the template that I'm using to create my EC2 instance, my virtual machine. This is the instance type, which is a T2 micro, the general purpose freebie version. I've got an EBS, which is the passport hard disk type thing, and so on. So it's low to moderate network performance and so on. It's just confirming that it's got everything that I wanted. The security group is allowing all ports, and we know that. If I want to click on here and see more detail, I can see more detail about what I've selected and check that what I've selected is correct and the tags and everything. And then I can just launch. And when you launch, one of the things it needs to do is allow you to access that virtual machine later on. So what it does is it's either going to create a new key pair or choose an existing key pair. I'm going to create a new one and I'm going to call it witches key pair, if I could type. And I'm going to download that key pair. And that's basically like a passport for me to get onto my virtual machine. So let me open this and see what it looks like. So I'm going to open it with Notepad. And you can see it's basically a really long password to get onto my machine, my virtual machine. So I'm going to launch my machine, my instance, and this is how quickly it launches. It launches very, very fast. I'll show you. If I click on here, it'll almost be ready already. Is it ready yet? You can probably hear my dog snoring in the background. Sorry about that. So is it running? Status check not happened. Okay, so it's still pending, but normally it happens very, very fast. Okay, so there we go. It's running already. So that's how fast it happens. So that was all I needed to do to get a server up and running. So now if I go to this server and I want to connect to it, it's not quite running yet. Let's just do a refresh until it's running. In a minute, it'll be running. When it runs, I'll just use that key pair that we just looked at, this secret key, if you like, here, and I'll be able to get onto that server. So, and then I can do stuff on that server as if it's just a normal server in my ordinary environment, but it's in the cloud instead of on my on-premise environment. So I've showed you everything right now for this. This is taking a while to come up. I'm not sure why. I've shown you everything I need to show you for now. and this is the first lab, and we'll show you later on some more about instances and so on. They're still pending. I'm sorry, I'm not sure why it's still pending. Usually it's up very fast. So believe me when I say this would normally get an instance in the cloud running very, very fast, and you'd be able to start using it pretty soon. But not right now for some reason. Okay, end of lab, and I'll see you in the next one. Some more EC2 terminology. So your virtual machines can be either Linux or Windows or Mac OS, and there are actually other types as well. The architectures, that means your CPU type, can be ARM or x86 and so on. You can choose different types of CPU according to your need. There are some graphics ones too, which start with a G. So you can have different types of instances. So they can be general purpose, or they can be optimized for a particular workload. So some of them are optimized for RAM. They normally start with R. Some of them are optimized for compute, and they start with C. Some of them are optimized for graphics, and they start with a G, and so on. And there's various networking capabilities and disk capabilities and so on. And as I said, there's lots of different types of AMIs that you can use, either your own custom AMI that you build yourself, or you can use a community AMI, which normally comes from the marketplace, or a packaged AMI, which AWS provides. There's multi-purchase options, so you can create an EC2 instance as an ordinary EC2 instance, which is an on-demand EC2 instance, or you can create a reserved instance, an RI, again, another terminology that doesn't always make sense. A reserved instance means I'm going to definitely use 3 computers this year, all year round. So I'm going to pay for those up front and get a cheaper version. You basically get, it's like going shopping in the supermarket. You get a discount if you buy up front. And so, for example, you know, if I'm going to buy 50 virtual machines this year, and I know I'm going to use 50 at least, if anything I'm going to use more than that, then I might buy 50 up front and I get a 50% discount, for example. Spot instances they're virtual machines that you don't really care when they run, so long as they run at some point. And you basically bid for a low price on the timing of those instances running, and you can get a lot cheaper compute time for that. So for example, if I know that I need every day to process some logs on my system, but I don't care, so long as it's within the 24 hours, it doesn't really matter when it happens within 24 hours, then I can say I want to bid on a spot instance at a really low rate, and typically it will run at 3 o'clock in the morning or something like that, but it'll be a lot cheaper, and that's fine. So any bargain shoppers will love AWS because of these options for purchasing virtual machines. So as I said, you can purchase virtual machines on demand, and then you pay the normal price. No long-term commitments. You can start it and stop it whenever you want, kind of thing. You only pay for it when it's running, though. And reserved instances, you have to make a commitment that you're going to use that number of instances for the whole year or for a whole 3 years, depending on how much of a discount you want. If you say, I want to use, say, 50 instances for a whole year, you might get 50% discount. And if you say 3-year commitment, you might get even more discount, like 70% discount. It can be a really significant discount. It depends on the time of when you order this, how much discount you're going to get. It goes up and down all the time. The savings plan is another option. It's you need to talk to AWS about the flexibility there, because there's all kinds of options there and all kinds of ways to save money. Especially if it's a really big company with a lot of compute, you can save a lot of money with a savings plan. Again, spot instances we talked about. At 3 a.m., very few people are using Amazon EC2 instances in the Northeast America region. So you can save up to 90% on your AWS virtual machine costs, EC2 costs. So that's a really nice option. Now, just to know, some people use these options like spot instances for load balancing. So for example, if I know that I'm going to get more demand for my service on a particular day, I might use spot instances to satisfy that demand, so that I pay less money for the increased demand than I would normally, things like that. So this is just a little bit more information about the on-demand options. So this is the normal default option for purchasing a virtual machine, an EC2 instance. So this is how it works. It basically has per second billing. So you're only billed while the instance is running, and it's only on the per second basis. There's associated resources such as storage capacity and so on. They'll be billed regardless of instance state, so watch that. So if there's some storage that you're consuming, that'll still be charged even if the instance is off, so be careful of that. If it's attached to like an EBS, one of those hard disks I talked about, one of those passport hard disks, if it's attached to that, you'll still be charged even though the instance is not running. The storage is still allocated to that instance, so it's still charged, so be careful about that. On-demand instances are isolated, but they run on the same shared hardware as other customers. So if you want something hyper secure where no other customer runs on the same hardware, you don't want an on-demand instance, you want a dedicated instance. On-demand instances are on shared hardware. So many other customers might be using the same actual underlying hardware. In most cases, it really doesn't matter because they're so isolated. The chances of another customer getting into your hardware or getting into your instance, it's very, 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 very slim. And especially AWS is getting more and more secure every day. So it's really not a worry unless you're kind of a banking company or a very high security services company, something like that. Then you'd want a dedicated instance. But for most cases, on demand is perfectly fine. And as you can see here, each host, so the actual host is the actual hardware. Each host can be running many different EC2 instances, virtual machines, from different companies, and they can be different sizes and so on. So all on that underlying hardware, many things can be running. The default purchase option is on demand. So this is the default purchase option, and it has no interruption. So you never lose your EC2 instance or virtual machine. You always keep it going. So for example, with spot instances, that's not true. Spot instances, if your bid price suddenly is not enough for maintaining a spot instance, you'll get a little alert saying that spot instance is about to be taken over, and the spot instance just disappears basically. And you have to take that into account when you're using spot instances, that it might only be running for a small period of time at any time. With an on-demand instance, that's never going to happen. The interruption will never happen. There's no capacity reservation with on-demand. The pricing is very predictable. There's no upfront cost. You just pay as you go, but there's also no discount. So that's why some people prefer reserved instances, so they get a discount. On demand is great for short-term workloads, especially for testing workloads, for unknown workloads also, and for apps that cannot be interrupted. So if you never want your app to be interrupted, this is probably the option for you. So for spot instances, things are different. Basically, the way spot instances work is AWS is trying to sell off its unused capacity in off-peak times, so when there's not a lot of demand for AWS. So you kind of bid on how much you're prepared to pay for a spot instance, and AWS will give you a spot instance if your bid is at the right price for that particular time period. For example, 3 a.m. is a really common time period for AWS to start giving out spots, because hardly anyone's using AWS at that time in the morning. A lot of the backups and stuff happen between 12 and 3, but after 3, few people use anything until about 7 or 8 in the morning. So that time period is a really common time for spots to be running. So if you bid on a spot price of say 90% cheaper than the normal price for a particular instance that you want, you'll probably get it at about 3 or 4 in the morning, for example. So never use a spot instance for workloads that cannot tolerate interruption. So basically only use a spot instance if you know that it's okay if it goes up and down at different times. And it also has to be non-time critical. So if it's something that has to be done by 7 a.m. in the morning, don't use a spot instance, because you don't know if demand is suddenly going to be high at 3 in the morning because something big happened or something. So some days you won't get the spot instance. Some days it won't come because demand is too high at that time. And it's very bursty, which means the capacity goes up and down. And it's very sensitive cost-wise, because so if you bid 90% discount, then some nights you won't get a spot instance. If you bid 50% discounts, you'll probably get it most nights. So just be careful of the cost sensitivity there. So we talked about reserved instances. So this is where you say, I'm going to buy 50 computers this year and I'm going to have them running all year, and that's the minimum I'm going to have running all year round. So I reserve it for a whole year and I get, say, a 50% discount. A 3-year term, I might get even more. I might get like a 70 or 80% discount depending on the time when I do this. So normally you would say, I'm going to use this type of EC2 instance, like a T3 or an M3 or what have you, and I'm going to have 50 of them, and I'm going to buy them for a year up front, and so I'm going to reserve them, and I'm going to get a big savings. You pay some of it up front, or you pay all of it up front, depending on how much discount you want. So this is dedicated EC2 instances or dedicated virtual machines. And in this case, what that means is it's on a hardware server that is dedicated to you. So it's going to cost more money. This is where you don't want to share with other people or other companies on the same hardware. So it might be because you're a bank or a security company or something like that. Most people don't need this because AWS isolation makes sure that different companies can't see each other's virtual machines anyway. But just in case you're a really, really hyper paranoid security company or bank, this dedicated host option does exist. It's much more expensive, of course, but you know, it provides that for you. So there's a little bit more to dedicated instances. For dedicated instances, there's a number of different purchase options. Generally, you're paying for the actual hardware. You're not paying for the instance itself, the actual virtual machine on top of it. You're paying for the hardware. You've got per second charges in option A here, default shared. There's no capacity management required at all. That's in option A here. Option 1, default shared. The second option is dedicated host, where you pay for the host itself and no instance charges. and there's capacity management is required in this dedicated host mode. You have to be careful that you don't go over the top of the capacity for that hardware. For the third option is dedicated instances. You don't own or share the host, but extra charges happen for the instances, but you do have dedicated hardware. So in other words, you don't manage the host, but you do have dedicated hardware, so nobody else can use your hardware. So they're the three options.